This is a kinetics problem. We're told that this reaction is first order and given a value of k, or actually we're given the half-life, and we want to determine first the value of k. We know for first order the half-life is equal to ln of k over 2, so we can easily solve for k, ln of 2 over t1 half, and put in our values. And our numerical value is 0.006795 seconds, or reciprocal seconds. And with 3 sig figs, it's 6.80 times 10 to the minus 3 reciprocal seconds. How long will it take for 84% to react? Now, if 84% reacts, that means that 16% remains at this given time. So we go to our integrated rate law for first order. A of t to a0 is equal to negative kt. We know k from the previous problem. We're trying to solve for t. Initially it might look like we have two unknowns here, but if we remember that a of t is going to be 16% of a0, we can calculate a of t divided by a0 as 0.160 times a0, that's a of t, and now we divide by the initial concentration. If we do this, we see the initial concentration cancels out, so we do not need to know what that is. And in fact, any given initial concentration is going to have this same result. So we can substitute in and solve for t. So t is going to be equal to the natural log of at to a0 divided by negative k. This can be the natural log of 0.160 divided by negative 0.0067955. We'll go back to the unrounded value so that we don't introduce rounding error. So this would correspond to 269.7 seconds. If we want our answers in minutes, we're going to have to do the conversion. 60 seconds is equivalent to a minute, and we get 4.49 minutes as the answer for the amount of time it takes for 85% to react. The next question is if 0.50 molar of reactant is initially present, how much is present after 5 minutes? So start with our integrated rate law. First order reaction. We're going to be solving for a of t. So initially we have to expand this using the law of logs, or properties of logs. And we finally get to ln of at is equal to minus kt plus ln of a0. Okay, so we can put in our values. Minus k and 5 minutes. This is only going to work if the units are consistent, so we're going to have to do a conversion. A minute is equivalent to 60 seconds. So we see here, now our units all cancel. Our initial concentration is 0.50. So we have ln of at is equal to negative 2.039, and to that we're going to add a negative 0.6931, So ln of AT is equal to negative 2.732. So to calculate A of t, we have to raise e to that power. And this numerically comes out to 0.06509. Rounded off to 2 sig figs is 0.065 molar. The last question is, after 3 half-lives, what percent of reactant will remain? So the same result is going to be obtained regardless of the order of the reaction, because the half-life is the time for 1/2 of the reagent to remain, or to be consumed. So at the start, we have 100% of our reagent. After 1 half-life, it goes down to 50%. The second half-life, we're down to 25%. 3 half-lives, 12.5%, which rounded off to 2 sig figs is going to be 13%, our answer. If we were to continue with this, after 4 half-lives, we would be at 6.25%, and finally down to 3.1%. Okay, and these numbers are going to be especially useful to remember. But our final answer, 4 half-lives, 13%.